Well, look what the cat dragged in today. Good to see you. Welcome back to our next video. This one will be on design specifications. This comes out of element C in component 1. And of course, this is all about doing more research. By the time you get to working on design specifications, you're concurrently working on so many other assignments that you'll find quite a bit of the information does start to overlap. So here's the introduction. Although the work of a product designer relies heavily on imagination and creativity, it differs from the work of an artist in that a product designer typically has functionality or marketability in mind. An artist may have the freedom to form any combination of materials, colors, and textures into any size or shape to create an end product without regard to function. A product designer, in contrast, must work within multiple constraints and must constantly focus on both form and function of the final product to ensure that the final design meets all the requirements necessary to make the product successful. So are you a designer? Are you an artist? Are you an engineer? You're kind of a combination of all of them. You do have to put on a few different hats in this class. Let's look at the next paragraph. Engineers use a written document called a design specification to clearly define the features and performance needed for a design to successfully solve a problem. Writing a design specification occurs as soon as the problem has been defined and is essential to the process of generating potential design solutions. The design specification explicitly states the criteria that the final solution must meet and the constraints that will be imposed on the design solution. This means in addition to research, you're also going to be required to do some writing. Some technical writing, in fact. And some of that technical writing will be to create your design specifications, to determine what your constraints are, what your limitations are, what your parameters are. This assignment should help you with laying the groundwork for all of that. You've already written a problem statement or are concurrently doing so. And based on this work and your research, you'll create a design specification for your product. Your resources, engineering notebook as always, and some electronic device connected to the internet. You should have at this point already started to dive into your similar solutions and probably maybe have started the similar solution matrix. Certainly that assignment is something that can be concurrently done or should be in the works as you go forward. Then you have your design specification documents. When you click that link, it brings you here. There is a presentation. It's 27 slides long. It has a lot of good information in it. There's also a concept test survey example in here. I highly encourage you to look over what has been provided as of 2013 from PLTW and then take this information and turn it into your own. It is 2020 now, so you might want to think about what genders you're actually asking about if you do at all. Is age important for your product? Does occupation matter? Basically, they're showing you that you ask a series of questions. Try to keep those questions yes or no, very binary. Provide them an ability to explain if they want to or describe if needed. I would encourage you to create a Google form for this. It's probably one of the best places to create a survey, at least at your disposal. Then you'll see they may explain something, give some sort of scenario, and provide, hey, in this scenario, which concept do you think is the best one? This gives you a chance to test the ground, to see what your potential customers, your potential end users. This doesn't even have to be anybody from the list of people I've already found. You could blanket this all over the place and see what kind of feedback you get. Just be ready for a lot of data. Notice at the end that they're thanking the people for their information. This is a good step to take. You might need to come back to these people later on. It might also be a good idea to collect some basic contact information from them. This activity is worth 75 points total, broken into 3 different criteria. We're looking at the elements of design criteria, design constraints, and validation. Above 22 to 25 points for this column, above 20 to 22 points for this one, above 15 to 20 points for this, above 5 to 15 here, it's a big range, and above 0 to 5 for this one. You'll probably shoot for somewhere 20 or higher. And of course, this rubric is provided all the way at the end of this activity if you choose to look at it there as well. This is what I'll use to score your work. Let's dive into that procedure. Consult with your customers or intended customers and complete the following in your engineering notebook, followed by creating a specification document with, I'd recommend a Google Doc, to include in your project proposal. Use the information you gather to craft your design specifications. You could choose to do all of this work in your engineering notebook and then transfer it to a Google Doc. You could choose to do it in a Google Doc first and then transfer what you need to your engineering notebook. You could choose to write code for a website that collects the data and organizes it for you and puts it in place. Maybe that's your jam. However you do it, make sure that you have access to this and you can provide it to me, and make sure this data is kept as secure as possible. Google Drive is a good place for this, especially if you are capturing any kind of contact information for any individuals that you may reach out to for the concept test survey. Number 1, who is the target consumer? Below, you'll find a list of criteria. You should divide these up among your teammates. Each team member will then identify specification requirements necessary for a successful solution related to each assigned element. Be as specific as possible and include measurable values. Did you notice those things are underlined? For example, use within 1 second, the device must warn the vehicle driver and disengage the cruise control when the car attains a distance of less than 50 feet directly between itself and another vehicle. That has very specific requirements. It has very specific and measurable values within 1 second. Not a second, 1 second. The device must warn the vehicle driver and disengage the cruise control when, that's an important qualifier, the car attains a distance less than 50 feet directly between it and another vehicle in particular. This is better than saying the device must warn the driver and slow the vehicle when the car is too close to an object. Okay, well, how close is too close? And when you say that it must warn the driver and slow the vehicle, how does it slow it? Does it press on the brake? Does it simply take off cruise control if it's activated? Does it just decelerate by not allowing you to press the accelerator, or disengages the accelerator? There's nothing specific there. It doesn't say another vehicle, it says an object. Is it all objects? There's lots of objects out there when you're driving. Be specific. Be sure to identify the sources of the information that you base each constraint on. Add additional criteria as needed. This means you have to do quite a bit of research that you may not be super comfortable with. You can't just go to Google and try to type in a question and find what additional criteria you need, or information that's very specific about the type of product that you might have to test down the road if you choose to create something similar to it. In other words, you have to heavily think about what it is your product will be doing, and then what might be criteria of the material, the way it's put together. Look at other objects that are out there. You are already doing research on them, and try to figure out what types of tests are conducted on those and what types of specifications are already provided for those. But you have to take the time to do it. Research, research, research. Here's that list. Customer needs. What does the customer want or need? Pretty straightforward, but you have to ask them. You're not the customer. You may not even know the customer. And if you can get into the head of the customer, you can start to help dictate what that customer might want or need. They're not really gonna know, so you have to pull it out of them. Performance. What must the product be able to do? Now, be specific. Target cost is another thing. What is the anticipated cost to the consumer for this particular type of product? What kinds of things need to go into this product? How much money would be spent developing it, making it, manufacturing it, distributing it, getting it to the customer, creating the surveys? What profit do you want to make on top of this product? What is that consumer paying for? It's also good to look at size and weight. What size should the product be? Is it still usable if it's that size? How small can it be? How big can it be? How much should it weigh? Is it going to weigh a lot? Is it going to weigh a little? With my product that we developed at training, it was supposed to be portable and mobile, and you were supposed to be able to lift components and set them down on a desk. When we started, that thing weighed 600 pounds per component. Nobody was going to lift that. You might even want to consider what are some weight restrictions on a product. If it's a particular type of product, there might be a reason that it shouldn't weigh more than a particular amount. Should an umbrella be 20 pounds? Should it be under a particular weight? Should it be over a particular weight? Let's look at aesthetics. Are there preferences in the appearance features of the product, like color, surface treatment, shape, material? Are we talking about texture? Are we talking about the way that it looks? Are we talking about the elements and principles of design from IED? Yep, absolutely. Be sure that you describe those. So, is there a specific type of material or a type of material that we should be using for this product that we hypothetically might be designing, or that are being used in the similar solutions that we've already found? What are they? Describe them. In all of this research that you've done, what are the safety and legal issues that might be out there? Are they being addressed already? Identify potential safety and legal issues that might arise from people using your product. You never know what people might do with it. You have to think that part out too. Is it too small that a 3-year-old shouldn't use it? Is it too heavy that an octogenarian shouldn't be using it? Did you know that octogenarian is actually a word? There it is. I love ergonomics. My keyboard is ergonomically designed. Most of you hate typing on this thing, or at least you have in the past. I also like the ergonomic design of my mouse. They go together. Ergonomics is very important. You should consider this in your design. Pretty much everything that you guys are coming up with the exception of maybe one topic idea, ergonomics is going to have a huge play. Think about the operating environment of your product or similar products that are out there trying to solve the same problem. Identify the environmental conditions relevant to the manufacture and use, not just how it's made, how it's used. Think of things like temperature or corrosion. Is there dust or dirt, and does that have an impact on how your product is made or used? What about pressure or humidity? What about vibration, noise, the degree of abuse it can withstand, or really just a limitless number of other things that you might need to consider as far as how this product will be used? Umbrellas definitely need to be able to get wet, definitely need to be able to be opened and withstand all that wind. You're really concerned with how they collapse. What about global environment? Will the product include any toxic or dangerous substances? Are phones, heavy metals, probably a good reason for us not cracking them open and go digging inside of them, though I'm sure many people do. What about the end of life for your product? When it's involved with the global environment, if we throw this thing out or recycle it, is that dangerous? Is that bad? Can your company get sued because your product was bad for the environment or dangerous for people to use? People are dumb. People will put products that you make in their mouth when they're not intended to be. The number of times I've put this phone in my dog's mouth and then also held it while at the toilet. Oh my God. Think about those things. Service life. What is the required service life of your product or ones similar to it? Product life is the anticipated length that the product will be produced before it is replaced by a newer or iterative version of it. In other words, are you planning for obsolescence? How long before your product probably won't work anymore? You have to think about durability and maintenance as well. Will the product require routine maintenance during its service life? So many products I own require routine maintenance, and so many companies don't want us to maintenance them. They want to be called out to maintenance them. I don't call them. I look it all up and do it myself. Is that okay? If so, you should answer the following. What specific parts of the product must have easy access for maintenance? What's the anticipated maintenance schedule for them? And are special tools required? Oh, so many special tools. How will those tools be acquired? There are literally things for my roof that I can't go buy because I'm not a roofer and I don't have access to them. Oh, so irritating. Will replacement parts be required? Probably. And if so, can people access them? This is why if you ever buy a fridge, dishwasher, washing machine, or dryer, don't buy from companies where you can't get the parts. And then what other additional criteria can you think of that your team might need to put in here? That was all number one. Number two, as a team, prioritize your list of criteria from most important to least important. Number three, list applicable constraints that the designer must then work within. Be specific. In other words, listing time as a constraint is not acceptable. You must state specifically how much time is available for the design process. Hey, that Gantt chart's going to be really useful for things like that. 4, attempt to obtain validation of each criterion and constraint by multiple qualified representatives from each of the following groups: end users, stakeholders, experts. Gotta find 3. Gotta catch them all. Pokemon. Create a design specification document. So something like a Google Doc, maybe a page on a website, or an embedded document within a page or a website for your project, and include the following things: the name of the product, designer, target consumer. Number 4, the design specifications organized according to priority. Hey, if you go back and you look at number 2, you were supposed to prioritize them. If you didn't do that, do it. We're going to look for that, especially when we get to the end. So down here at the bottom, you see that we have the ability for you to give me a website URL or for you to upload a file. Google Doc, website, embedded doc in a website. However you want to get it to me, that's fine. Your design criteria, design constraints, and validation. They're for you to determine what they are, how deep you go, and how much you try to validate. The more, the better. At this point, I want to go back to the design specification documents, and I want to remind you there are 3 things here. One of them you can find on the assignment itself, but if you need to print one or you want to have one as a Word document or save it as a Google Doc, it's right here. That's the rubric. There's the concept test survey example. It's the only place you can really find this thing. Please do make sure you alter it if you want to use it, because none of your products will probably line up with the questions. And then defining design goals and design requirements. This is the design specification presentation.
Woo! PowerPoint.
Well, that brings us to the end. Design specifications. Very important part of this process. Hopefully at this point you are getting a good solid idea of what you'll be doing, and having gone through this myself, I can tell you it's not a quick process. Think carefully about these design specifications. I encourage you to put one person in charge of this particular topic, and then use everybody else as a resource as they also try to complete other assignments. But don't forget that everybody in your team needs to have input. Although you're going to have one person responsible for it, they're not the only person working on this. Those are just my suggestions. I hope you have a great day. See me later. If you have any questions, send me an email. But most importantly, have a great night.